good stuff. So the performance we've touched on, how is that achieved in a hardware level? And in a moment we'll go into scale up and scale out and that level of performance. So for hardware based, what technology do you use within the storage, and what is the hardware platform?
Okay, many questions in one. Looks like. One thing, it's a scale out solution, software defined. We are not really depending on the hardware layer underneath. We need an x86 system, and mostly that's it. It's commodity-based hardware we are using. Nothing special at the moment. We achieve our performance out through the architecture. Some very beneficial points are the way you can set up a system, thinking about the needs of a customer or of the application regarding performance, regarding capacity, or regarding availability. We designed the system that way that some of my colleagues designed the whole I/O stack by themselves. That means we wrote the whole I/O stack for our Linux kernel. We wrote that, and that gives us latencies within our software stack of about 40 microseconds, which is really one of the fastest systems in the market. And everything on top is then related to the media, which can be a spinning device, for example. Then we have to add a couple of milliseconds. Or it can be NVMe flash, it can be SATA flash, or it can be even persistent memory, which we already showed a year ago on the Flash Memory Summit, for example, in US, that we can support that. And on top of that, we have then the latency based on the protocol, which on iSCSI or ISER or NVMe OF, maybe later on, might be adding a bit of to our latency as well.
Great. So, we talked about performance and scale up and scale out. So, how is a Datera system built? Where do we start? So,
Okay.
I've got a requirement for storage. I've come to you guys because you tick all the boxes. And what do we do? How do we get it on site? How do we stack it up, rack it up, and basically present it to the hosts?
Okay. Back to the basics, I would say.
Yeah.
Starting bottom line. Yes, as I said, it's commodity hardware. If you talk to me regarding a project, usually my first questions is about the performance requirements the customer has, what kind of applications they want to use, in which direction they are thinking about moving in the near future. The good approach with Datera is that you don't have to think about a 5-year term. What do I need within 3 to 5 years? That's a question we want to avoid, because in nowadays no one can tell you what I would need as a customer in 5 years. It's unpredictable. That means we go that approach that you can start small with what you need now and easily exchange later on to more demanding workloads, to more capacity requirements, or whatever you need in the future. That means we start with a 3-node cluster. Minimum, I always prefer a 4-node cluster, and that's a question about availability, of course. And after you set up the cluster with the typical network settings we have to have, you create the cluster from one node, and then you join the other nodes to the running cluster. The join process is about a 90-second process, then it's done. We distribute the software as an ISO image. That means you install the ISO image on a node. We take over the node, as I told you already regarding, for example, the software stack has to be fast. We adopted a lot of kernel processes and modules to have that very high performance system. And we have a couple of things which is going a bit more into the architecture. Might important that we have a control plane, which, if we talked before about Kubernetes, for example, thinking about the same approach within these new technologies on compute like Kubernetes, we did for storage. That means we have a layer which is controlling the whole cluster, doing all the management and networks, all the network settings, the management, monitoring, failure scenarios, detection, and these kind of things. And then we have a data plane which takes care about the data and the placement. And these two processors are running on every node. That means there's no need to install a management node or a master node. This is something we don't have. We deliver everything within the ISO image. You install the system, you install the cluster, and then you can present to a customer. Usually, my experience with setting up such a system, it's a half-day approach. Installing into the rack, cabling up everything, even install the switches if necessary, set up the cluster. If the network preparation is done well before, it's a half-day. Done deal. And then the customer can already have the first volumes attached to his applications.
That's rapid deployment. That's
absolutely
gone are the old days of white coats and clipboards, and yeah.
And it's not only about the setup; it's even thinking about how do you deal with traditional storage at the moment or in the past. If you think about 3 years old storage, what do you have to do? You have to think about data migration to the next generation. And that our approach helps here as well. It's not only very fast in deploying, even you can then do a rolling upgrade on the technology underneath on the hardware level in that way that you include new nodes with a newer technology, for example, other vendors, whatever else, and then you can take out the old nodes from time to time, and the system is taking care about the migration to the new nodes. And this is something which is done that way that you don't face any performance impact on the front end side. And the migration can take some time maybe, but it's sustainable performance during that time, and it's invisible, seamless.